Alright, so let's get to work on this review sheet. First, you have to be able to do these graphs, so let's remember some. Absolute value graphs is V shape, so that moves right 4 down 2. So there it is, the slope is 1. So we're going to draw that. There's no shading because there's no greater than or equal to or less than or equal to, so there's your V shape. This guy is a hyperbola because a minus in the middle. So it's right in the center because there's no movement on the x and the y. So it goes 5 in the x direction, 4 in the y direction. That's the box. And that's where I draw my asymptotes from corner to corner. These things are just to help us know where to draw it. They're not really on the graph. Alright, it's x is in front, so it has to cross the x-axis, and it's going to go in the x direction. So the parabolas go this way and this way. And that's the vertex of them right there. They're pretty wide because it's so spread out. Alright, this one has a plus in the middle equal to 1, so that's an ellipse, an oval shape. Right in the center, it's going 3 in the x direction and 2 in the y direction. So just do your best to draw an oval shape. Okay, y equals x minus 1. That's just a line starting at -1. The slope is 1. So just going up this way. All right, parabola, but it's x equals, so it's going to be opening to the right. So it means the vertex is -3, -2. And it has no stretch or shrink to it, so it's going to go 1, 1, 2, 4. And that's about all I need to do. So get those points on there. So there's my parabola. Okay, and it should be more rounded. It shouldn't be pointy like that, but all right, absolute value again, but a less than, and it's no equal bar, so it's dotted. So you need to go left 2 and down 3. It's normal slope, so it's going to go here. Slope of 1 over 1. So I'm going to dot it, or dash. Alright, and less than means I'm shading below it. Okay, alright. Good old square root function moved up 2 places. So remember your basic square root function looks like this, a little half shape, like half of a sideways parabola. And let's see, up to 2. So right there goes 1, 1, goes 2, 4, kind of does opposite of a parabola. Okay. Alright, there you go. Here we got a normal parabola, so left 4, up 1. It's upside down and it's been shrunk, so it's half, the height is half of what it was. So instead of going 1, 1, I'm going to go 1 and then a half on each side. Instead of going 2, 4, I'm going to go 2 and then 2, so I'm doing a half every time. Alright, that's good enough to draw it. It's just wider than normal. Oops, I kind of missed that. Alright, over here, a circle. So radius 2, no center is in the origin. So it's going through these spots. Just try to do your best to draw a circle. Okay. So moving on to here. I have a parabola. I have the focus is at 4, 2, and my directrix is at x equals -2. So that means that my vertex is right in the middle of those. So 1, 2, 3. There's my vertex. 3 in, 3 that way. And it has to go around the focus, so I know it goes this way. So I know that this equation is going to be x equals with a y squared. It doesn't have a negative because it's opening to the right. The focal length is 3. The p-value is 3. So it's going to be 1 over 12 over here because p is 3. And the center, the vertex, is 1, 2. So I'm going to have a positive 1 and then a -2 right here. Okay, solve the system of equations, linear combinations. So these are 2 lines. I think I can just subtract these because look, these match right here. So 2x minus 10x is -8x. These cancel when I subtract. -3 minus 21 is -24. So I easily get x is 3. I'm going to plug that back into this top equation. So 2 times 3 is 6, minus 9y equals -3. So take away, I get -9y equals -9, and then I get y is 1. So 3, 1. All right, over here, I'm going to use my data to do a quadratic regression. So to do that, I would have to, you might want to clear your calculator first. All right, and then we are going to press our stat button and edit. I'm going to put these numbers in. Right, so we want the equation. We want a quadratic regression. So I'm going to be pressing stat, going over to calculate, then number 5, quadratic regression. I'm going to go to store and alpha trace, grab y1, calculate. So it says the nearest hundredth, so that's 2 decimal places. So y equals 0.20, 0.20 x squared, I don't need that 0, plus 0.82, so 82 right here. X, and then minus 0.03. All right, now I'm going to try to plug in 30, so I'm going to clear that away, and because I stored it, the equation's in there if you look at it. So I do alpha trace, grab y1, plug in 30, and my answer is 204.55 to 2 decimal places. Okay, if you wanted to look at a picture, you would do second y equals, turn on that plot, and then do zoom number 9. And so you can see the quadratic right there. Now, after you do this, if you turn your plot on, this picture is messed up. So if you're going to go and try and graph regular stuff, you don't really need to plot it, but I just did. So I'm going to clear the calculator to get all this stuff out of here. Okay, so now my graph is my regular picture. Okay, let's see. So I want to write the equation for this parabola. Well, it's facing up, so I know it's going to be y equals, leave some space, x and squared. The vertex is at 3, negative 2, so minus 3, minus 2, so right 3, down 2. The distance here is 2, the focal length, so that p-value is going to be 2. Okay. Over here, let's see, my vertex is right there, so this is facing to the left, so it's going to be x equals, parentheses, y squared. There's going to be a negative because it got flipped over. So let's see, 1, 2, 3, 4 is my focal length, so I'm going to have 1/16 with that negative right there, and my vertex is at negative 2, 1. So the 1 goes with the y, so minus 1 and then minus 2 here. Okay. All right, so tell all about this parabola. Well, the vertex is right 2, up 1. So it might help, right 2, oh my gosh, I'm blind, so that should be a 5. All right, so 5, 1, it's facing up because it's y equals, and that's positive. Okay, my focal length, so that's kind of hard to tell here. So 1 over 4p is equal to 2. So if I cross multiply, I get 8p equals 1. So p is 1/8, and 1/8 is 0.125. So my focus is going to be inside. It's going to change the y value. So 5 is going to stay the same, but the 1 is going to gain this much, so 1.125, or 1 1/8 you could say. All right. So number 7, more parabolas. Okay, so this guy, another y equals, so let's see, left 1, down 2. Okay, and my vertex, so negative 1, negative 2. Let's see, my focal length is 1 because 4 times 1 would be 4. So p equals 1. That means my parabola is facing down though, so it's facing down because it's negative, and that means my focus is right here, so it's negative 1, negative 3. Axis of symmetry goes right through the middle, so that's x equals negative 1. And my directrix is 1 unit above the parabola, so that's y equals negative 1. Okay. All right, let's see. All right, so changing the format here. So I'm going to have to move my 10 over, so 3y minus 10 just to get it out of the way. I got x squared plus 4x. I'm going to take half of 4, square it, so that's 2 squared, which is 4. I'm going to add it to the other side as well. So I have 3y minus 6, and this turns into my parentheses that I wanted, x plus, and I squared 2. So don't forget to put the square. All right, you could do a couple things here. You could move the 6 now, and then divide by 3 later, or you could just divide both sides by 3 right now. That would create a 1/3 in front of this parentheses, and this would turn into y minus 2. So my final answer is y equals 1/3 x plus 2 squared plus 2. So this parabola opens up, and the vertex is left 2, up 2. Okay. Over here we have x equals, and it's going to be a negative, so this parabola is going to open to the left, we know. Okay, so let's begin. Move the 26 over, so I got x minus 26. I got negative 2. This part right here, I'm going to have to take out the negative 2, because I don't want to divide everything by negative 2, because x can't divide by negative 2 easily. So I'm pulling out the negative 2 as I write it, so that becomes y squared. By pulling out, I mean I'm dividing it out. I'm undistributing it. All right, I'm factoring basically. So if I divide this by negative 2, I get positive 6. All right, so half of 6 is 3, and 3 squared is 9, so plus 9. So by doing this, I'm really creating a negative 18. That's the effect of all these numbers. So negative 18 there means negative 18 here. So I got negative 2. This factors into y plus 3 squared. And let's see, 18 and 26, so 36, so 44. So I got x minus 44. So my final answer is negative 2 y plus 3 squared plus 44. So my vertex is 44 and negative 3. All right. So a good old quadratic formula problem. Let's see. So for my quadratic formula, I need everything on one side. So this x is going to move over. The 6 is going to move over as well. So 2x squared plus x plus 5 equals 0. There's my ABC. So let's find our discriminant. My discriminant is b squared, so 1 squared, that's 1, minus 4 times 2 times 5, so 4ac. So it's going to be 1 minus 8 times 5 is 40, so 1 minus 40 is negative 39. All right, so I think I'm ready to write my answer. I got negative b, so negative 1, plus or minus the square root of negative 39 over 2 times 2, which is 4. So I can't leave that there, so my final answer is negative 1 plus or minus I radical 39. 39 is just 13 times 3, so it doesn't reduce at all in my radical. And no reducing, I'm done. I just have to pull that I out. All right, here we're going to identify these shapes and then graph them. So it's a plus, there's a 1, different numbers here. This must be an ellipse. All right, this one, minus total indicator with all these squares, that is a hyperbola. All right, so there's going to be a little part where you have to like identify. So I'm going to do that real quick. So here, no fractions, not equal to 1, plus in the middle, it's a circle. Right, fractions, minus in the middle, equal to 1, that is a hyperbola. Okay. All right, so let's go back and graph them. So left 1, and let's see, my center is negative 1, positive 2. So negative 1, 2. And I'm going to go 2 in the x direction each way, and 4 in the y direction. So here. All right, so pretty simple. All right, the hyperbolas are the ones that are annoying. All right, so my center, x is not moving at all, y is moving left, say up and down 1, I mean. All right, we'll do the asymptotes in a second. So 0, negative 1 is my center. I'm going to go 5 in the x direction to make the box. So 5, 5, 3 in the y direction. All right, so there's the box. Okay, that's how I draw my asymptotes. All right, now we look. X is in front. So it has to go in the x direction, so it has to go right and left. It has to cross the x-axis. There's my vertex. I go up towards the asymptote. And here's my other vertex. I go towards the asymptotes. So draw two parabolas. Okay, so now time for my asymptotes. Y plus 1, so I'm using the point. So the x value, x is 0, y is negative 1. My slope of this asymptote is 1, 2, 3, 1, 2, 3, 4, 5. It's these numbers right here. So this right here is 3/5. So this turns into y plus 1 equals plus or minus 3/5. And then x minus 0, I'm just going to put x. I don't need x minus 0, it doesn't do anything. All right. Nice, juicy, long. All right, so my center here, -2 and 3. My radius is a square root of 9, which is 3. So -2 and 3, and my radius 1, 2, 3. All right, so there we go. Nice, easy circle. Oh, another hyperbola. Let's see, my center is 1 and 2. So 1, 2. I have to go 2 in the y direction, and 1 in the x direction. So a little tiny box right there. My asymptotes go corner to corner. Okay. My hyperbola, the y is in front, so I draw it in the y direction. Draw it up and down. Okay, so remember, the only thing that's there are these two parabolas right here. The rest of it's just like helping us, like how to draw it. So my asymptotes both go through this point. So this number is going to be 2. This number is going to be 1. And my slope is 2 over 1. So 2. So I'm going to have y minus 2 equals plus or minus 2. And then x minus 1. Okay, so down here, some more identifications. We have a parabola and a line. Here, plus in the middle, no fractions. This is a circle. Everything's squared. This one right here, minus, everything squared. That is a hyperbola. Squares and a plus with a number here. That's the radius squared, so that is a circle. This is a line. Nothing squared. Okay. All right. This guy here, parabola, line, nothing squared. Okay. So those have to be kind of like, what you notice right away. So when I have a parabola and a line. So a parabola and a line meeting together, might meet twice. So it might be like this and that, or it might meet once if the line's down here, or maybe not at all. But either way, these are both equal to y, so I'm going to set them equal to each other. So x squared minus x plus 3 is equal to negative 2x plus 5. Okay, I'm going to bring everything over to the left. So plus 2x, so I'm going to factor. So I got x squared plus x minus 2. All right, so you make your puzzle, but this one's easy to factor also. What multiplies a 2 and makes 1? Well, 2 and 1. So it has to be positive 2, negative 1 to make that work. So my answers are negative 2 and 1. Those are the beginnings of my points. All right, so negative 2, I'm going to plug that into here. This gets me 4 plus 5 is 9. Put a 1 in there. That gets me negative 2 plus 5, which is 3. All right, so a circle and a hyperbola. This is the worst. So circle, and this hyperbola is opening in the x direction, so it probably looks like this. It probably has 4 places that it crosses, unless the hyperbola is right on the edge of the circle. So let's see. So this one I think I'd rather do linear combinations. I'd rather do the addition method. If I multiply this one by 3, then that'll make these two cancel right here. So I have 3x squared plus 3y squared equals 75. And this guy is 2x squared minus 3y squared equals 5. So add them together. These cancel. I get 5x squared equals 80. Divide by 5. I get 16. So my answer is plus or minus 4. So let's try our answers. X equals 4. So when x is 4, I'm going to put it here. Well, 4 squared is 16. Plus y squared equals 25. Take away 16, I get y squared equals 9. That means I get y equals plus or minus 3. So that just created 2 answers. When x is 4, I got 3, and I also got negative 3. Well, when I do x equals negative 4, going to do the same thing. Put a negative 4 here. Well, that still creates a 16, and it makes the same thing happen. So negative 4 gets me positive 3, and negative 4 gets me negative 3 as well. I don't need to solve it again because I just had that. All right, a circle and a line. So this is not, I know these are lined up, but these are not the same things, so I can't get rid of them because they're not squares down here. So I think what I'll do is move this 2x over. So y equals negative 2x plus 3. And I'm going to plug it in right here. Okay, so I'm going to have x squared plus negative 2x plus 3 squared equals 18. So I'm going to take that off to the side. Negative 2x plus 3. Negative 2x plus 3. Now, you could choose to write this as 3 minus 2x, 3 minus 2x. It's coming out the same. Either way, this multiplies to 4x squared, and then negative 6x, and another negative 6x, and then finally a plus 9. So, I got x squared, this is plus 4x squared, minus 12x, and plus 9 equals 18. So we'll clean that up. I got 5x squared, minus 12x, and I'm going to have to take away 18, so I get negative 8. Okay, so I'm going to have to factor this. So, make my puzzle. 5 times negative 8 is negative 40. I got negative 12. So I think we'll use, What makes 40? 10 and 4, 8 and 5. Oh, sorry, I'm silly. 9 minus 18 is negative 9. So that would be 45. That's why this isn't working. All right, there we go. So now 15 times 3. In fact, negative 15 times 3 multiplies negative 45, makes negative 12. Got to divide them by 5. All right, so let's see. I got x minus 3, and this one 5x plus 3. So my solutions are 3, and what makes this equal to 0? It would be negative 3 over 5. So, kind of annoying, but whatever. So these are the beginnings of my answers. All right, so I think I'm going to use this guy right here. Y equals negative 2x plus 3. So if x is 3, that's easy. That'll be negative 6 plus 3. Negative 6 plus 3 is negative 3. But for this one, if I have negative 3/5 plus 3. All right, so I get positive 6/5 plus 3. I got to get a common denominator. So 6/5 to turn 3 into a fifth, I would have to multiply by 5. So 3 times 5 is 15. So 6/5 plus 15/5 would be 21/5. Or the decimal that makes 21/5. So 4.2. All right, last page finally. All right, so this is in my calculator. So I have reset my calculator. I got the first one, 2x squared plus 3x plus 1. Down below, I can't enter this unless it's solved for y. So this has to move over and become negative 2x plus 1. All right, so we'll graph that. I can see that they are hitting each other twice. So I'm going to do second calculate, number 5, enter, 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 and there's an intersection, 0, 1. And I'm just going to, 0, 1 is right there. All right, then do second calc again, number 5, and I'm going to move closer to the other one. Enter, enter, enter. And then it's negative 2.5, comma 6. So negative 2.5 and 6. All right, so there's the line. Oh my God. And we're just sketching it here just to kind of prove ourselves. I don't know, start the problem. So it doesn't have to be perfect, but, you know, just sketching it. Okay, so to determine the center and the radius of this circle. So I'm going to have to put this in the right format. So I have x squared and 2x. Those need to be grouped together. Leave a little space. Plus, now group the y squared plus 6y together. Leave a little space. Okay, we're doing completing the square. Half of 2 is 1, and 1 squared is 1. So add 1 there, so I add 1 here. Half of 6 is 3, 3 squared is 9, so add 9 here, and add 9 there to be fair. So I've created a perfect square here, and a perfect square here. And this number is just adding up to 25. Alright, so I got x plus 1, and over here we got y plus 3. So my center is negative 1 and negative 3. The radius is 5, the square root of 25. Alright, last one. So we're going to sketch a little picture. So the balloon, let's see, a water balloon is thrown in the air, catapulted in the air. So this equation right here, I tell it's an upside down parabola, and I can tell that it's starting at 2.4 height. So this number right here is 0, 2.4. That's that y-intercept. Because when you plug in 0 for your time, and this is your height, right? It's starting at 2.4, and it's like going like that, and it's going to hit the ground. Okay, and splat. Blah. Okay? Alright, so that's my picture. So if I get asked for the y-intercept, I can tell it's that number right there, because when I plug in 0, that's the only thing left. Alright, how high after 1 second? So I gotta plug 1 into this. So negative 4.9, 1 squared, plus 27 times 1, plus 2.4. So you type that into your calculator, or Desmos, and you will get 24.5. 24.5, remember to put units. So how high is it? 24.5 meters. Okay. All right. At what time does a balloon reach its maximum height? So I want to know what time is this. What time value is that? That's what I'm trying to find out. So that would be the x value of my vertex. So remember the formula is negative b over 2a. Okay, it's the beginning of the quadratic formula. So that time that this happens is negative b, my b is 27, over 2 times negative 4.9. So put that in your old calculator there, and you'd get 2.76, rounding off to 2 decimal places. I think that's all it made anyway. And 2.76 seconds. That's the time. All right, time. How high? All right, next one. What's the maximum height of this balloon? So I want to know when it's at that time, how high is it? What's the height of it? What's the y value? So I got to plug 2.76 into this problem. So negative 4.9, 2.76 squared, plus 27 times 2.76 plus 2.4. So you will show me this work on your test. You'll show me what you're doing. Right, and then you put it in your calculator. So this comes out to 39.59 meters. That's how high it is. All right, when will it hit the ground? So that's a new thing. I want to know the x-intercept. So x-intercept for this kind of problem, I need the quadratic formula. So I got to do my quadratic formula, which means I'm going to need my discriminant. I'm going to figure that out first. So my discriminant is 27 squared, I don't know that one, minus 4, a is negative 4.9, and c is 2.4. So this comes out to 776.04, because here's my a, b, and c. All right, so it hits the ground at a certain time. I would normally put x equals, but it's t now. So negative b, so negative 27 plus or minus the square root of this number over 2 times a, so 2 times negative 4.9 is negative 9.8. All right, so again, how I found this number here, I did 27 squared minus 4 times negative 4.9 times 2.4, right? That was that. All right, so now I'm about to make a fraction. Put this in, negative 27. I can only do one at a time, so plus the square root of 776.04 over negative 9.8. So there's one answer, but that doesn't make sense, right? Because that's the one back here. So one of these answers is negative 0.09. Well, I don't want to type this in again, so I'm going to go grab it and change that plus to a minus. And there is my answer I want. Now 5.59, this would change this 59 to a 60, so 5.6. 5.6 seconds. So that is when the balloon is going to hit the ground. All right, and that is it. Good luck. See you in class.